Hi everybody, especially the AP people. We are going to be working on what we call PV diagrams today, or pressure volume diagrams. They always put one of these on the OAP test, and so I want to make sure I went over how to do this. Let's take you back a few months ago, though, when we were talking about work, and we said that work equals force times distance. So right before winter break, we were talking about the fact that work equals force times distance. Well, we got to remember that we just also learned a formula in which the force was also equal to pressure times area. Remember that old triangle we made sort of looked like this? We said that pressure equals force over area. So if you cover up the F, because you're trying to find force, it was P times A. So what I'm going to do here is I'm going to take this F, or this PV, and I'm going to plug it in for that F up there, and that gives me this, P times A times D. Otherwise, W equals bam. Now, if this distance is in the Y direction, and that area, once again, is base times height, or I'm sorry, base times length, then you could say base times length times height equals volume. So work also equals P times D. This whole area times distance that I just put a green square around, that is the same thing as volume. So W now equals PV. That's where they got that formula that you see here. Now this is going to be the work done on a gas at a constant pressure. And so if you change the volume of that gas, you're definitely going to be doing work on it. Okay, so the pressure is throughout the whole gas, and the change in volume of the gas during the process. Now you're going to have all these PV diagrams that you see down here. And if you notice this first one here, you just have a triangle. And since you have pressure on the y-axis and you have volume on the x-axis, if you find the area under the curve here, so that gold area, that will end up representing the work done. So let's just look at this one over here on the right-hand side where I put the big triangle. Okay? So if I want to know the work done on this particular gas, I'm going to take P, or negative P times delta V. Okay? And if you notice the pressure there, they don't give any numbers, so we're just going to make some up. So we're just going to make this final volume a 1, and then it'll be somewhere like 2 here, and 3 and 4. So that's about 4, something like that, to change. And then this will be, let's say 1, 2, 3, 4, 5. So let's put the pressure at 5. At 5 what? I don't know. Let's just make it 5. So I'm going to put in a 5 here. Now the final volume was 1. We're going to subtract that from the initial volume, which was 4. So therefore, I'm going to get 5 times a negative 3. But you got to remember that's negative P times V, so it's actually a negative 5 times negative 3. So that means the work done on this gas ended up being 15. We'll just say it's joules because work is measured in joules. Okay? So it's that easy to do. You just find the area under a curve. Now I want you to look right here at this next one. I wish I could make it a little bit bigger. But there's one part of this graph that you see right here in the middle where pressure is going up, but the volume is not changing. Well, if there's no change in volume, let's look at this right here. If that part right there is 0, then there's no work done on that gas. So just remember that you sort of have to look at these graphs as you go along here to find out whether there's work done. Now, next thing I want you to look at is, that didn't quite work. I want you to look at this graph down here. I know it's very, very, very difficult to see. I might try to make it a little bit bigger here. Let's see if we can do that. This one here is also going to be on the test. So let me scoot it up. And if you notice, you got 4 different lines there. And here you just got to know some vocabulary. Okay? The prefix ISO, I-S-O, means same. So if I have something that's ISO, it means same. So let's now combine that prefix with some other words. So I could have isothermic. That means you have the same temperature. I could have isobaric. Remember, like barometer means pressure, so that means the same pressure. This means same temperature. Okay? You can also have iso, what we call choric, or isovolumetric. That means same volume. Volumetric. You have the same V. And then there's another one that's called adiabatic. You got to remember adiabatic, there's no heat adiabatic, I spelled that wrong, sorry. There's no heat that gets in or out of the system. So if you look at these, let's look at letter A. If you look at letter A, it's going straight down, so the pressure's changing, but the volume's not. So that means letter A would be isochoric or isovolumetric. This would be letter A right here. Okay? Now let's look at letter D. Letter D goes straight across, so the pressure's not changing. And if the pressure's not changing, that would be isobarometric. So I could put letter D would be this one. Okay? Now that's when it's a little bit tough. Remember, at the same temperature, that would be like Boyle's law. So as pressure goes up, volume goes down. So letter C is representing Boyle's law, so that would be this one. And since no work is getting in or out, that means Boyle's law is going to go be real efficient. So letter B is going to be your adiabatic one. And so you'll see that particular problem on the test as well. Okay? So a little C-dab action there. All right, finally, let's get into doing one of these problems here. So you'll have one of these problems on the test. Raise this up a little bit if it'll actually go for me. And what we have here is an ideal gas that absorbs 5 times 10 to the 5th, I think is what it is. Let's check that. Hold on. I can't really see on here very well. Hold on here. So I got, well, I cannot move this for the life of me here. Hold on. Okay, now we're good. So I'm going to go ahead and write down what was given to us. So that 5 times 10 to the 3rd joules is going to be the amount of thermal energy that we're absorbing. So I'm just going to put 5 times 10 to the 3rd. If you want to put 5,000, that's good. Whoops. 5 times 10 to the 3rd there, joules of energy is going to be our Q. And then it says that while doing 2 times 10 to the 3rd joules of work on the environment, well, you got to remember, if it does the work, that means it's going to be negative. So I'm going to put a negative 2 times 10 to the 3rd right here. And it wants to know, compare the change in internal energy. We got to remember that internal energy is the energy inside of U. So that's what we're looking for. And U equals Q plus W. So I'm simply going to add those two numbers together here. So you got the 5 times 10 to the 3rd plus the negative 2 times 10 to the 3rd. All these are in joules. And so the energy, the internal energy of this is going to be naturally 3 times 10 to the 3rd joules. Okay? So pretty easy stuff. This is from last chapter. Now the next thing it wants to know is this. It gets a little bit trickier. Part B says if the internal energy is now drops by 4.5 times 10 to the 3rd joules, and 7.5 times 10 to the 3rd joules is expelled from the system. Let's talk about what those two numbers mean. The change in internal energy, this is now question number 2, so let's do the change in internal energy, is now a negative 4.5 because you lost it, okay, times 10 to the 3rd joules. And it also says that 7.5 times 10 to the 3rd joules is expelled from the system. Well, once again, that's going to be Q. And since you're getting rid of it, it's got to be negative. So that's going to be a negative 7.5 times 10 to the 3rd joules. Now what it wants to know is this. You have to figure out, I keep losing my place, find the change in volume. Well, let's figure out what this whole question is going to be. If I have U equals, or change in U equals Q plus W, and you got to remember from up here at the very top, W equals P times D, right? So I could say that Q equal or plus P times V there. So let's figure out now what we're going to put in here. And once again, it says find the change in volume assuming constant pressure is 101 times 10 to the fifth. So let's plug all these numbers in. So we're going to have delta U. Oops. We're going to plug these numbers in. Negative 4.5 times 10 to the third joules equals, our Q was negative 7.5 times 10 to the third, plus P they gave you at 101, I think that's what it was. I'm screwing this up. I think it's 1.01, yeah, 1.01 times 10 to the fifth, because that's normal atmospheric pressure. You got to figure out what V is. Well, if you switch it all around and solve for V, you end up getting somewhere around, I think it's like a negative 2.97 or negative 3, something like that. It's going to be times 10 to the negative 2. And since all of this has to be in metric, it's going to be cubic meters. Okay? So pretty easy problems to do. And just make sure you're ready for those on the test. Right? Have a great one. Bye.